Okay, in your notes is a little exploration that we did in class as groups. I let everybody have about 15 minutes to explore. So I'll go over the explanation so everybody that wasn't there or is needing to go back over it will have it. It said to put these four functions in the calculator and to graph them, and to try to notice what point did they have in common. What point do they have in common is what we're trying to look at. So if we graph them, there's 2 to the x, then there will be 3 to the x, then there's 4 to the x, and then there's 5 to the x. Okay. Now, what point do they all have in common? Well, it looks like they all go through that point right there of 0 and 1. If I put in the calculator 0, it goes through 0 and 1, and that's the point they have in common. So if I was to change to all the graphs, you'd see it never changes. There's 2 to the x, 5 to the x, 4 to the x, 3 to the x, 2 to the x. So it goes through 0 and 1. So my first point asks what point do they have in common. They have 0 and 1 in common. What else do they have in common? It is what wasn't part of the exploration, but I did go over this as a class. If I were to draw this, it says that it goes through 0 and 1, which is true. This is going to be 2 to the x. But it also goes through 1 and 0. Also goes through 1 and 0. Now, if I were to graph 3 to the x, it would go through 0, 1, but it also go through 1 and 3. So my question to the class was, well, if 2 goes through 1 and 2 and 3 goes through 1 and 3, what would 4 and 5 go through? Well, 1 and 4 and 1 and 5. And so the other thing they have in common is they're always going to go through 1 and the base. All right? Now, we were supposed to answer some other questions. And some of the questions were, well, let's just start with the first. It says, analyze the functions for the domain. So the domain, well, if we look at this picture right here, it's going to be all reals. If we look at the range, well, look what's happening. It's getting really, really close to 0. And if we look at our picture, it's getting really, really close to 0. And if we go to our table, we can see how at negative 97, it's really, really close to 0, but it hasn't crossed it, and it never will. It never will cross 0. So we're going to put that the domain is y is greater than or equal to 0. That is our range. All right, now, what else does it ask us to look for? It asks us to look for, this should be y is greater than. I don't know why I put the equals, because it never touches 0. Okay, y is greater than 0. All right, and then it asks me to look for if it's continuous or discontinuous. Continuous means I can put my pen or pencil on the line and never pick it up. I can just keep drawing forever and ever. I could do that for both of them, right? I never have a hole, I never have a jump, I never have anything like that. So these are continuous. Okay? Next question was, are they increasing or decreasing in behavior? Well, we've got those two, but if we look at all of them, we can tell we're reading left to right, reading left to right. They are increasing. So they are increasing. They are an increasing function. Okay? The next part says, are they symmetric? Do they have symmetry? No symmetry. No symmetry. Do they have extrema? In other words, do they have a high point or do they have a low point? No. No extrema. And when I say a high point or a low point, that means it curves. It does a curve, so it would come up and curve back down, or come down and curve back up. That's our high and our low. That's what extrema means. No, this doesn't do that. All right. Asymptotes. Well, we said it has to be greater than 0, so our horizontal asymptote is y equals 0. Our horizontal asymptote is y equals 0. And then for the end behavior, well, as the limit as x approaches negative infinity of f of x is going to be equal to 0, because it's getting really, really close to 0. That y value is 0. And the limit as x approaches infinity of f of x is going to equal infinity, because it's going on and on and on forever. It's going on and on forever that way. Okay? So there is 1 on the discovery.